Hello everyone, Eric Galinier from SITA. Eric Lemasson helped me to put up these slides. He's over there, hiding. He preferred to stay over there than speaking, so I will have to speak. I'm going to introduce you SITA briefly, and I'll speak about my department, and I'll present you more specifically what the Megaswitch is and what is the challenge that we're facing. I came here with Eric to understand more RDMA and what the industry is doing with it and what potentially we could do. We've been working for about a year to try to determine what could we do on the Megaswitch to invent the next generation. As you will see, we have some a lot of redundancy on the hardware that we would like to use, and RDMA might be one of the options. So who is, well, SITA? It's the world leading specialist in air transport communication and the IT. We provide a lot of IT solutions to the airlines, IT infrastructure, services, and full solutions. We use the most extensive network in the world to provide this IT infrastructure to the airlines. If you want to know more about SITA, there is a portal, a website, sita.aero. A quick history: SITA has been founded in 1949, 63 years ago, by originally 11 airlines, including Air France, KLM, Sabena, Swissair, British, Danish, Norwegian, and some others. We have then worked, we have provided IT services for all along for 63 years to the airlines, and we have a lot of very close communication and ties with all the airlines. Actually, the airlines own SITA. And we are actually installed in 200 countries. Every time an airport opens, they call SITA to have a communication to the rest of the world, the ATI world. And if you want to know more about the history, you can go to SITA Aero and SITA History. So I work more specifically in SITA messaging, and we provide the backbone for the operational business of the airlines. They can exchange all kinds of information, including flight plans, reservation system, every type of information that you can imagine. We have also air-ground communication that go through our systems. One of the main protocols that has been invented in '49 is the Type B, and the airlines still use this protocol to exchange information. So it's very old, but it's very reliable and powerful, and it really does the job. So we have hosts when the airlines are installed in airports. They create a host which internally switches their internal traffic, and then they connect to us to interact with the other airlines through, again, the Type B messages. So we have a lot of different subsystems, sub-protocol, sub-services, web Type B, AFTN gateway, which is the same type of messages, but if it's for the civil aviation, then we use, some airlines use X400 to connect to us, that we're going to translate into the Type B, so we can communicate with other airlines. And we have also SMTP. We do a lot of transformation on the message, Spec 2000, Skyform, Skyhost, etc. What else? So this is how it looks like. This picture is a little bit old. Now we could add, here we could add the Type X, because the air transport industry is moving to the next generation of messages, which are XML based, but the payload is still a Type B message. But they want to be able to use XML to extend the type of content that they can exchange. So, oops, sorry. So you see here they can connect via X400 or SMTP. But the goal is really to go through type B because this is really the way they communicate, and they have been communicated all along for 63 years. So now I'm going to go to the next slides, which really shows what is the platform used to switch these messages. And the platform used is the Megaswitch. It's a relatively old design. I'm one of the architect and developer that worked and developed the Megaswitch in 1996. So it has been online for a while, but we have seen a lot of different generations now. When we started in production in 97, we were at 20 messages a second. Now we are in the thousands of messages a second. The growth is pretty important every year for the Type B. Even though everyone is saying for the last 20 years that Type B is going to disappear, we still see a lot of growth constantly. So the Megaswitch is IBM P-Series based. It has been replaced in 2006. It was a sequent architecture before. We use AX OS 6.1. We have 16 P5, 50s, and 20s. And we're going next month in P740. So we're going to replace all the hardware to increase the performance that we need based on the projection and what we observe. We have to constantly increase the capacity. There's an acceleration in the exchange because the number of passengers growing requires more. And I mean, more capacity, and then we have to constantly upgrade our systems. We have also, for the configuration and the operational management, we provide to operators 2 blade servers which connect to the application, the Megaswitch itself, and they can monitor, configure, and operate the Megaswitch. And of course, we work, constantly on monitoring this system 24/7. We use DS storage 4500. The next generation is DS 3500 for next month. That's coming online. The Megaswitch application is really 1 million lines of C++ code. I would say 1 million plus. So it's a lot of code, essentially in C, but also in C++, but also C, Perl, PLSQL, ProC, OCI, SML, Corn Shell. So that's pretty much the description, the high-level description of the Megaswitch itself, which is one of the most critical applications within SITA. And I wanted to add that the outages on this application are counted in seconds or minutes, but when we go into the minutes, we start having all the VPs and CEO of the company on top of us, because this has a lot of consequences. When this system is down, potentially planes are stuck on the tarmac. They are not allowed to take off and things like this. So this is very, very, very critical. So we have requirements for the reliability and the availability that are very, very, very high. So now there is a little movie that I think will, I hope, show you a better picture of what the Megaswitch is about. So if we could start the movie. Let me see. So this is here, right? And which one we take? We take the, I don't see the extensions aren't showing. Yeah. Okay, we took the, I can't see it.
Try a quick time.
Maybe. Yes, quick time is fine.
Yeah.
And the sound.
I think it's, didn't like.
Why is it the thing isn't like this one then?
Yeah, try that. There we go.
Okay.
Type B messaging, the air transport industry's proven standard for communication for more than 50 years, connecting the worldwide air transport community and used by more than 700 airlines and 1,300 associated companies worldwide. Type B messaging facilitates communication of mission-critical information between airlines and their business partners, such as airports, aerospace companies, air traffic control, customs agencies, as well as air-to-ground communication. SITA's contribution is switching more than 30 million messages a day via over 600 hosts and over 20,000 end-user connections worldwide. SITA provides unrivaled native access to Type B via MATIP, IBM MQ series, and others, as well as through gateways like SMTP, X400, AFTN, and any fax and telex machines in the world. SITA is providing key features such as message storage, tracking, and retrieval, lights-out capabilities with end-to-end remote management from Atlanta and Singapore, full disaster recovery without loss of any data in less than 15 minutes, quadruple safe store of all messages, logs, and trace information, periodic tape backup of all information including transfer to a secure location, and the most advanced and state-of-the-art technology. SITA's Megaswitch systems utilize fully redundant hardware, latest IBM P-Series hardware, IBM Total Storage Fast T900 technology, Oracle 10G database technology, Oracle DataGuard technology, and dual IBM TSM solution for backup and restore. Fiber infrastructure utilizes redundant high-capacity, state-of-the-art dark fiber with 2 diverse paths between the 2 SITA data centers and microseconds latency between centers. SITA Megaswitch provides for messages that are completely secured in 4 synchronized message databases across 2 data centers, and the ability to retrieve messages from 4 different locations in real time. All files are periodically backed up on tape and transferred to the other data center. Failure of 2 of the 4 servers can be recovered locally, providing less than 1-minute interruption for recovery on backup servers. In the case of a complete site outage, the Megaswitch application utilizes Oracle DataGuard to switch the standby databases to primary in less than 7 minutes. Once the databases are primary, the application is launched in less than 5 minutes, providing less than 15 minutes total outage for full disaster recovery activation. Damaged servers can be replaced quickly due to the use of standard off-the-shelf hardware components, and replacement servers can be rapidly rebuilt by utilizing off-site backup tapes.
Okay, I wanted to mention that this movie is about 5 years old, so we are not in 10G anymore. For Oracle, we are in 11G R2. As far as the volume of messages, we are not at the number that they say here, 30 million. We are more at 60 million a day. So in 5 years, we doubled, actually, and that's about it. Hmm? Here, right? Can see here. Okay. Okay, this is what we have in logical view today. I will focus on the. So we have a data center 1 here and data center 2 here. Everything is doubled, so we have 1 Megaswitch. These 4 machines here represent a Megaswitch with 2 storage independent, completely independent Oracle. They are not linked via Oracle rack. They are completely independent and managed by the switch here, meaning that the switch makes sure that the synchronization, that the 2 stores are synchronized at all time. We have a very high-end proprietary HA solution, which makes sure that at all time we have a status of all the 4 machines, and the switch knows if one of the store is not synchronized with the other, and will take the decision by itself to bring it down in case there is some unsynchronization between the two. Then we have several types of mechanisms to recover the store. If the switch goes down, the other switch, hot standby, will take over in less than 1 minute, most likely in half a minute, but in the new generation coming next month, it's less than 5 seconds. And in the movie, they were saying the full DR activation was in 15 minutes. Now it's less than 5 minutes for a full DR with full content. So we have data guard between the 2 centers and the 2 stores here and here. And that's what we use if the data center here goes down, the second one, with one command. The operators have one button on their configuration management that will activate the DR Megaswitch again in less than 5 minutes with everything up again. So we use a SAN to replicate for MQ, but that's a different topic here. We are just going to focus on the Megaswitch. So that's what we have today. So you see that we have a lot of unused hardware here. Out of 8 machines, we have 5 that are not used, and most of the time don't do anything. What we would like is to put everything at work. It will serve several purposes. First, we wouldn't have to do what we call a switchover between the 2 switches. They would all be active simultaneously. And also, we will remove the data guard replication, because we would have constantly all the stores or the database servers up and running, and they wouldn't have to be synchronized via an external Oracle tool. So that's what we're trying to accomplish. And again, we tried last year to look on the market what was available, and we didn't find anything very substantial or that could really help us. This is why we started to look at RDMA. So if we go down to a lower level, and I'm focusing here on the switches themselves, the messages arrive to the active switch via network protocol, MQ or X25 or IP, and they are stored or used while they are in transit in a segment of memory, shared memory segment. The configuration is also stored in a shared memory segment, a different one. We use ISIS, which is a middleware to establish and make the communication between all the different servers of the Megaswitch. We already configure we already synchronize the configuration shared memory segment, but we don't do it for the messages. So what we will need to have this second switch active is to have this shared memory segment synchronized at all time on this switch and potentially on the others. But that's the current situation today. So we see that this switch is constantly low level usage on CPU because it doesn't do anything. It's just ready to take over with the configuration already loaded. So in case of this one going down, the configuration is already loaded and it just has to come up very quickly. And what we would like is some kind of mechanism here. And we don't know how we could call it, but potentially a distributed or virtual or synchronized shared memory segment between all the 4 switches. Then in this case, all of them will be active simultaneously. And we don't know yet if RDMA can accomplish this, but this is this is what situation we are facing. And I was asked to show you our challenge. So that's what I've done here. So I don't know if anyone has any comment about or idea about how we could accomplish this. We have found a couple of companies. Eric found a company in Europe who was doing this on Linux, but for some reason they went out of business. They were, so I don't really know what it means. I thought the idea very useful, but maybe just me. So if we could come up with some kind of mechanism when one switch upgrading this shared memory segment here propagates simultaneously on all of them, we would have all of them knowing what the other, or at least having the same view of the others. Yes?